what you see in the picture is the cross-section view of a circuit breaker. In this video we'll understand exactly how the circuit breaker works and how the tripping mechanism cuts off the supply in case of fault current or faulty circuit. So the red wire, what you see is the supply. Let's say the current comes and then it's with the help of the screw bolted to this terminal of the circuit breaker, and here it goes, and this is a bimetallic strip, and here is the spring loaded arm, and here is the linkages. So this is a link, here is a link, and then this is the conductor. The current comes through this blue wire and then it goes to the bimetallic strip, and here you can see behind there's one more conductor or any metal piece which goes to this link, and here whenever the circuit breaker is on, this will go and hit or make a contact here, thus the current supply is taken out through this terminal. So this is the input terminal and this is the output terminal or outlet, simply we can say in layman's term. So now let's see what happens when it is working, like, alright, so these contacts are open now, the breaker is in off position, now it's on, the current starts to flow through the supply line, that's the red line, the current flows through this terminal, and here you have screwed it, so remember that it flows through this. If it's loose, then definitely there's going to be a problem with the circuit breaker, like arcing, or even the circuit breaker might trip. Any fault may occur over here. So through this it goes to this and enters the bimetallic strip. So as the current flows, the bimetallic strip gets heated up. So let's say the circuit breaker is rated for 20 amps. Till 20 amps nothing will happen to the bimetallic strip. Of course it will expand, but the expansion will be within the limit, it will not trip the operating links. However, let's say if the circuit breaker or the bimetallic strip is heated up more than 20 amps, let's say 40 amps or 50 amps depending on the overload or the thermal expansion setting. Let's say for example 40 amps, what happens is this expands and then the link is taken or pulled back so that the contact is open, no more current supply passes through. So now the current flows through this link and through this wire, through this contact, goes to the output terminal. Now let's see what happens when the overload gets. So this is how it works. I'll show it once again. So the current flows, it starts to expand, and as it expands, if it's above the limit, this is sliding down, thus releasing this link, and then the link is open due to the spring. The spring pulls it back. Let's watch it once again. You can see it's coming back, this link is released, and thus this is being pulled back and the contacts are open now. Now the breaker is in trip position. After it's tripping, it's in a center position. On is towards this, off is this, and when it's in center position, it's in a trip position. You got to reset it, and resetting depends upon the time the bimetallic strip comes to normal position. It has to bend back. When the current flows through it, the bimetallic strip gets heated up. When the supply is interrupted, the bimetallic strip cools down and comes back to its original position, and thus it cools down, allowing you to put off the breaker and reset it. Let's see now what happens. So after the bimetallic strip cools down and comes back to its original position, you will be able to reset the circuit breaker from the trip position. As I said earlier, on position is towards like this, which I have shown in the arrow mark. Off position is this, and the center position will be the tripped condition. And now I have pulled this lever back to let's say I'll show you once again. Now it's in off position and the contacts are open. Now you can rectify the fault and put it on, so that again the circuit is connected and the supply flows through. So this is how a circuit breaker works basically. In the future videos, we'll watch how the automatic circuit breaker or braking mechanism with the help of spring or any solenoid valve works. Let's see in detail and discuss about it.